Welcome, turning big data into fast data. I'm Kevin Goldstein with Neve Research. In general, turning big data into fast data is really talking about four things. It's talking about agility, it's talking about resilience, scalability, and simplicity. Hopefully at the end of this talk, I'll have convinced you that big data and fast data are really two sides of the same coin. And in many instances, you have to unlearn some of the things that you've learned. Done correctly, big data is the same thing as fast data. However, done incorrectly, big data will crush you, just like a bug. A little bit about ourselves. We are Neve Research. We're headquartered in Silicon Valley. We're an in-memory technology company that specializes in low latency, mission critical applications, leveraging microservices specifically. We're also the creators of the X platform, which is an in-memory next generation transaction processing platform that leverages the in-memory techniques and architectures. This is our third year at coming to IMC stuff, so we're really having a lot of time learning, and we'd like to share as well. We are, as you can tell by the content of the topic and as well the subject matter, we're really passionate about high performance computing, and we're up and running already in Fortune 100 to 300 companies. Where that 300 comes from is actually really funny, because our CEO was talking to a couple of different people, and the CEO of one of our larger companies that we were working with was there, and he said, yeah, we run in Fortune 100 companies, and she sort of piped in like 100 companies. We're at 278. What's going on? We don't want to be discounted. So we threw in this new categorization of Fortune 300 company, hashtag 300. Hopefully we can start tracking that and make it a trend. So let's talk about our growing need for big data, right? Let's talk about what we sort of expect to see happening as the years come by. We already know that data is growing at an exponential rate as well. We already know that data is growing at an exponential rate, but we only expect that to start growing a lot faster. In fact, by 2025, we're expecting to see something along the lines of 160 zettabytes of information flying across the wire at any given time, right? Where an incredibly small percent of that needs to be persisted, needs to be stored. However, a significant amount of that 25% of that data, actually has to be processed in real time. Not near real time, in real time. Some of the estimates that I like to talk about are Cisco's estimated that in 2017 we had 8 billion connected devices, and that by 2026 we're going up to 26 billion devices. Now those numbers are sort of staggering, so I like to throw in some simple math that if we said, this is one of my favorite math ones because it's overwhelming and underwhelming. If we said that each one of those 8 billion devices sent one message over a single year, we would have to be able to process somewhere along the lines of 100,000 messages a second in order to handle all that throughput. And by that same token, if we are processing every one message from those 26 billion devices that come from 2020, we would have to be able to process something along the lines of 300,000 messages a second. Now, this is sort of underwhelming because, yeah, we're never going to have to process every single message coming from every single smart device, right? We don't have that kind of throughput. We're not going through all of those latencies. But on the flip side of that coin, it's a little bit overwhelming because those devices, they're not sending a single message, right? They're not sending one message per year. They're sending tens and thousands or hundreds of thousands or even millions of messages per year. Interestingly enough as well, we are estimated that something along the lines of 70% of messages flowing across the wire are going to be information or location aware. That means that they're going to either be about geolocation or be geolocation tagged. A good example of that is collecting telemetry from vehicles that are moving, planes that are moving. They don't have a location tag, but they are all about movement of cars and movement of planes and movement of stuff. So it's 70% of that is location aware, even though it may not have location embedded in the message itself. Now, whenever you start talking about big data, inevitably you hear people starting to talking about streaming data, right? Because they're intimately related. That's where the fast data part of it comes from, right? So when we start talking about streaming data, we're talking about the 4 V's. And the 4 V's come in the name of volume, how much data we're dealing with, right? And that number is staggering already, and it's only growing. Currently, if you look at the market data sizes from the Opera market data feed, from options market data feed, we're moving at anywhere between 6 to 10 million messages a second, right? That is a lot of data coming through your system. And then there's that velocity, right? How fast can you process data? Not only do you have to be able to process the information itself, the actual message that you're receiving, but you have to make it available for other people to consume, and you have to make information about that message, right? So surrounding contextual information about that message available for people to consume as well. And then as we start to consume more and more data, we start to see a lot more variety. We don't have so much structured data happening anymore, but we got a lot of unstructured data. Now, big data and especially fast data, in often cases is the study of edge cases. Yeah. But you don't have to deal with variety because we're on Wall Street. But suddenly we end up having to deal with sentiment analysis, and we're pulling in Twitter feeds, and we're looking at social media feeds. So the fact that we're only dealing with very structured data holds true, but suddenly starts to break down a little bit more. It's not as hard and fast as it used to be. And then one of the hardest use cases is this veracity thing. The second you suddenly start talking about you're transferring hundreds of thousands of messages a second or tens of thousands of messages a second, you suddenly start you need to make sure that the data that you're working with, those reference data, that field of contact ID, customer ID, user ID, is that correct while you're working with it, right? And then people offload that. Then you put that into a storage device, and it becomes even more complicated to work with, right? Because people do move. People do change their numbers. They do get married. They do have kids. They do change jobs. Emails do go out of style, and they get a new email, right? How many of you have a Yahoo email versus a Gmail email from 10 years ago, right? So maintaining that veracity, it's not just difficult in flight. It's also very, very difficult once you put that data to rest. And that's something that we need to be able to take into account. Whenever I'm talking about these kinds of things of big data, fast data, flowing data, I like to talk about use cases because it's sort of hard to get your head around unless you're dealing with a use case. And the use case that I like to bring up right now is Spotify. Right? You all know what Spotify is, that streaming music service that allows you to, you enter your user preference, and it sort of just will stream you additional songs and additional music, and based off of your kind of preference, it knows that you like a new kind of artist, even though you've never heard him, it knows you're going to like it, right? And it'll get that content to you right off the bat. Now, what they did is they implemented a very classic Lambda architecture, right, where you got real-time streaming events going over the top, and you got storage events coming on the bottom, right? And all that stuff is being put into a Cassandra database. Apache Crunch is cooking it and, doing analytics and, passing all that stuff. And the numbers that Spotify has to deal with are truly staggering, right? They had something along the lines of 60 million active users streaming 30 million songs. They had 1.5 billion playlists just last year, and they streamed over 7 billion hours of music. And by the way, that 7 billion hours of music translates into about 291 million years worth of music. The entire rise and fall of the dinosaurs could have had a really good play tunes going for it. Right? Users have the choice of mixing and matching songs, of figuring out what songs you want to have, of following your friends, of following artists, of following, all these different things. And what Spotify does is it builds this play graph of things that it knows that you like, so it can dynamically and intelligently offer you new content. And this architecture worked well for them for a while. And then around 2016, 2017, people suddenly started saying, I'm questioning my revenues. I'm questioning my ad revenues, and I'm questioning my royalty revenues from the artist side, right? The problem with this particular architecture, because it's so complicated, and because you have sliding windows, and you have so much data points coming through it, is that they knowingly sacrifice consistency for speed. They had an 80-20 model, where 80% of the time they get it right, and 20% of the time they get it wrong. So suddenly, or not necessarily get it wrong, don't have the information. And that suddenly becomes interesting because advertisers suddenly pop up and they say, hey, I want to know not just that my ads went out to 1 million people, I want to know the exact number of people my ads went to. I want to know what times it got surfaced, who clicked on it, when they clicked on it, did this turn into a revenue event, or did this person see it for 1 second and move on, right? So these are pieces of information you need to know. And then artists suddenly came in and said, hey, 80-20, does this mean that you're getting 8 out of the 10 songs that I produced? I mean, imagine you buy that Michael Jackson CD, and you get every song but Thriller, right? And it's Halloween, right? You missed one song out of the 10, and that was really the one song that you're looking for. Another thing that ends up becoming a problem for Spotify was not necessarily the 80-20 thing. Another large one is they build a specific music graph for you. They build a specific profile of what your music looks like, what preferences you look like. So if you're a metalhead, for example, and you really like listening to Metallica, Trivium, Guns N' Roses, take your pick of whatever it is, it builds that profile for you. And you realize this is the music that it likes, and it'll be providing you more as more content becomes available. But what they don't take into account, that you may have a 6-year-old daughter, and your 6-year-old daughter is having a party, and next thing you know, you have to have unicorn-themed music songs playing in your house, and you're able to get one song, but you're never able to get it back, and you can't play any more. And because of the way that they tied that in, because of the way that they built your structure, means that, you know, unfortunately, that unicorn theme song didn't really make it to the mainstream. So if we take a step back and we look at what this looks like from a generic point of view, we realize that there's 3 major pieces, right? There's the data sources being separated from the data functions. And then there's the fact that we are being able to, we're transferring the data from the data lakes or the data sources into the functions, people that are providing that business intelligence, right? That business intelligence actually gets more and more complicated. As time goes on, as authoring gets more intelligent, right, those sources get very, very complicated. And this data, like we just mentioned, is actually only getting bigger, right? So it becomes very difficult if you start separating data storage from the computation. Right? This is a pull methodology, not a push. So when somebody says, hey, I need to run a new piece of analytics, I'm actually going back to that data sources, that data provider, and I'm sorting through 1 trillion records of information. Even assuming that I can get at that 1 trillion records of information quickly, right? Then you've suddenly got the problems that you're hitting edge cases. When you start dealing with these kinds of sizes, right, a 1 in a billion chance starts happening every hour. You're dealing with edge cases that really nobody ever has to worry about because it's mathematically insignificant. But at this size, it suddenly becomes significant. That actually is starting to happen on a day-by-day basis. And the other problem with this is data is not happening in memory speeds, right? I was actually speaking with somebody where the amount of volume that they're dealing with was growing every 3 months, right? And the fact that they actually have to go and do a risk analysis and pull things from database and have these rolling windows suddenly means that, hey, I want to have my value at risk. I want to know how fast things are happening. Come back in 2-3 days. You know, and my risk trader, my risk compliance officer, he needs to know this stuff right now, not in 2-3 days after it's too late, after I suffered a market crash, right? And lastly, these systems are very hard to build. Right? They take a long time. You have to architect a whole bunch of stuff out. You end up talking to data scientists. You talk data modelers. You talk to high-performance computing people. You talk into a whole bunch of different people that it takes a very long time to build these systems. And we don't have that luxury anymore. We have to be able to author systems quickly, easily, and cleanly. So what's the solution? The solution is what we're really looking for is we want to be able to operate on complex business functions that operate on incredibly large and disparate volumes of data in real time and produce intelligent, customer-focused results. What's an intelligent result? Let's just sticking with the Spotify example. An intelligent customer result says, hey, tell me about this customer profile. And they say, here's a list of 100,000 records of all the customers' information. What am I supposed to do with that? That's not intelligent results. I now have to go cook that and figure out what I'm supposed to do with that on an individual piece of information. That's not an intelligent result. That's a stupid result. I need smarter results, and I need it to be real time. So how do we move that? Well, we're already moving in the right direction. And when I mean we, I mean the industry as a whole, right? I mean all of us are getting better about what we're doing. What we've learned is that we've got to cook data in flight. And what we mean a lot about by that is making sure that reference data is correct, and making sure that number is correct, and making sure that email is correct, or that ticker is correct, right, or that CDOL is correct, and that you're referencing the appropriate account. And then we're starting to route it. We're getting a little bit smarter about how we route stuff, but we need to work on that push, not pull. Presenting information to people before they ask for it instead of waiting for somebody to come and ask for 1 trillion records. Then we're going to run some very large computations on it, and then we're going to store it somewhere. Right? And we need to be able to store that in a usable format, not in multiple formats in 20 or 30 different ways so that we can use it, but in a usable format, right? So in order to do that right, in order to get all 4 of these things right, where we're cooking in flight, making sure that reference data is correct, where we're routing to the right place, where we're computing at the speed of presentation, and then storing it, in order to do that correctly, we need 4 things in general, right? We need the simplicity for business agility. When that means that I have a new business analytics case to work on, that I have a new value at risk to work on, when I have a new pricing model to work on, I can't go back and redesign my entire system and embed it into this very large monolithic structure. I need to be able to snap it in. I need to work at the speed of memory, at the performance of memory. I don't have time to go and query things from disk anymore. I also have to have things running in a very reliable and performant manner. and have to be able to run large computations on it. So how do we get to each one of these things? Or, these things at the surface, they seem really simple. Yeah, simplicity, all right, that's easy to get up and say. And in-memory performance, that's also an easy statement. And these are all basically on the face of it, all very complicated things. But once you start looking a little bit deeper, it gets a little bit more complicated, right? What does cooking data mean? Cooking data means making sure that reference data is indeed correct, that you're dealing with the right customer account, that you're dealing with the right customer. My name's Kevin. How many other Kevins are there in this room? And making sure that you've got the right Kevin is not that easy, right? You have to be able to move with both the agility and speed of what you're working on as the company grows and as new business opportunities present themselves. And you have to present intelligent opportunities, right? And because you have to work in push, not pull, we're getting more and more intelligent routing, right? Where data is being presented to the correct pieces of architecture, to the correct pieces of software, instead of the correct pieces of software going and asking for it. But we're not there yet, right? Somebody presenting 1 trillion data pieces to the correct piece of software is better, but it's not exactly great. It's not exactly optimal. We need to be able to shard out on individual business metrics. We can't say, this is our trading table, everybody go work off of that and figure out what you're going to be able to do. You need to be able to shard out, this is your trading table, your position table, your limit table, your post-trade and pre-trade limit tables, right? You need to be able to shard out what it is you're trying to do, not just working off a single piece of information. And not only that, this is a big one, you have to be prepared for peaks and valleys. It's actually really common for people to deploy stuff and see that the computers are running at 50, 60, 70%. And like, that seems to be okay, we can move 10% here in any direction. But the reality is you have to be prepared for floods of data. You should be running at 20 or 30% of capacity so that there is a market movement, so when a big movie does drop, so when Michael Jackson does pass away, they don't think the internet gets broken because you can handle the capacity perfectly fine, right? You are going to be able to handle that flood of data. The next thing is about the speed, working at the speed of memory, and I can't stress this enough, being able to recalculate, figure out where things are, and present results in a timely manner. In fact, Gartner estimates that, 40% of all of these large data, of all of this fast data that's being processed right now, is being processed outside of the timely manner. That means that you're dealing with 40% of the computations that you're doing, if you want to think about it, even from the power consumption level. 40% of the power that you're using is relatively useless because it's outside of the usable time. Now, I've always had a hard time wrapping my head around 1 nanosecond, 3 nanoseconds, 40 milliseconds, 500 mics, 10 milliseconds. Those numbers are just small. And somebody suddenly says, hey, a nanosecond is 1 foot of light between a movement from one place to the other. And again, that's cool, but light, it goes too fast for my brain. So an easier way to explain this is, let's say I buy that thing from Amazon. Let's say I click buy, and my mouse starts spinning. If I'm working at the 2 or 3 nanoseconds, if I treat each nanosecond as a second, right? When I click buy, I'm waiting 3 seconds, 4 seconds, maybe up to 10 or 12 seconds. Whereas if I'm comparing things all the way at the bottom, if I'd clicked buy, I'm waiting for 10 days, right? The speed that we're talking about, the order of magnitudes that we're talking about is from seconds to days, going from 3 nanoseconds to 10 milliseconds, right? So that's actually quite important. Another thing that we want to talk about is the microservices and what they do. They bring you scale. They bring you agility. They bring you resilience. We're past the days where somebody stepped on a power cord and your entire system stops responding. More often than not, people push back on that power cord example because it's an outdated example. Everything's running on data servers, and data centers are in the cloud, and you don't have a power cord to step on. Okay, fine. So when you start talking about large deployments, when you start talking about 5,000 machines, 10,000 machines, 20,000 machines, things that are pretty normal inside data center deployments, you suddenly start to run into these edge cases again, right? Where you do have failing NICs, and you do have network hops, or network perturbations, and you do have hard disks feeling up, and you do have fans that suddenly stop working, and your CPU overheats and goes poof, and you don't know why because you weren't monitoring it. So this, the ability to recover gracefully from that in today's day and age is absolutely a requirement. The architecture must support deployment for reliability, but also it must support deployment for different versions. One of my favorite examples, and I have no evidence for this, but I personally feel every single time that I see Google Gmail going down, it's not because they got hacked or because they were dealing with an event, I feel that they probably backed themselves into a corner and they can't figure out how to upgrade it without doing a system cycle. And so it's a lot easier to say that we were dealing with an event, that we were dealing with hackers, because they're Google, they're dealing with hackers every day. And then admitting to the fact that, oh, no, we were doing a version upgrade to one of our core products and we backed ourselves into a corner, that's a little hard to deal with, right? And we can't suffer the same thing. We have to have a deployment methodology. And anybody who's worked on DevOps, you know that deploying and maintaining new versions and deploying and maintaining new schemas is incredibly difficult and incredibly time-consuming and incredibly expensive. And not just expensive insofar as the personnel, right? Expensive insofar as you make one mistake, something goes sideways for a little bit, and suddenly you're down. And suddenly your customers can't get to you, and you're now suffering reputational risk, and you've got a breach of SLA contracts, and a whole bunch of other bad things start happening. So it's not just expensive for the maintenance fees, it is expensive for actual usage fees, right? Another thing that we have to suddenly start dealing with is we have to start dealing with live storage and access. Even if we go back to the Spotify example, because it's just a good one that we're using right now. Even if I gave you a theoretical device and I said, here's a device that has 600 zettabytes on it, and we can access those zettabytes at the speed of light. So don't worry about the access time. But now I ask you to go and start doing computations on it. And you start asking about large computations. You start asking about things that have 10 million records, 100 million records, 50 million records. Right? Marshaling that up, even at something that's passed from the speed of light, but transferring it over to the place that is actually doing those computations takes a long time. Right? So it's not just the speed of access, it's getting the data to where it needs to be. It's that concept of data gravity, of being able to calculate on top of that data, that becomes very, very important. So we need to start keeping the data in the same place that we are keeping computations. If we go back and we look to this original problem, this original thing, and we say, hey, the data is separate from the compute function, and we're pulling this stuff via messaging, and we're pulling this stuff via marshaling, we realize that this worked for a while. It got us a lot of, it moved the technology forward, it enabled us to start dealing with big data, but this is not a viable approach anymore. Intelligent business logic requires the logic to draw on large volumes of data, and the larger volumes of data you get, the larger the edge cases that you're going to have to deal with. So what's the solution to this? Well, I mean, I've already talked about those 4 core tenements, or those 4 core principles. And we see this, everybody knows this, everybody's aware of the Lambda architecture. Is it possible to apply those core tenements in real life, in production? And the answer is yes. We've actually deployed this to the MGM Resorts International. Right? We are cooking in flight. We are capturing from disparate data sources, and we're storing and processing at the speed of memory, and we're bringing together multiple different data sources and combining them into one useful, intelligent metric. We're able to store things in memory in the same place where we're processing it. And if I'd like to throw some of the numbers at you, because they're just as impressive or even more staggering than the Spotify example. MGM International is a hotel chain that deals with 1 million rooms on a global scale, and they have 3,000 events a year. They have 6,000 restaurants that they have partnerships to deal with, and they have a customer base that ranges in the millions. Some of those customers have to have a very detailed profile, and some of those customers have a very sparse profile. Some of those people are landing in Vegas on a private jet, and other people are driving in their 1964 Pinto, right? And MGM International has to be able to provide personalized experience to each one of those people. You have to make sure that as I'm providing a new show, as I'm recommending a new show, I'm not recommending a show that you've already seen 4 times. But I have to be able to recommend a show that I know you're going to be interested in. And I'm not going to recommend you a restaurant that, you being a vegan, I'm not going to send you to Prime Steakhouse. I'm going to make sure that you have the options and the choices that you want. By implementing their system using these 4 core tenements of routing, of transferring, of cooking in flight, of processing, of data gravity, right? They were able to change their revenues from $250,000 a month to $10 million a month in 6 months. I like to call that business agility. Right? They went from running 50 servers with 120 gigabytes on each server to running 4 servers with 780 gigabytes on them. This is simplicity and performance. And once they learned that they have the ability, once they realize they have that concept of the microservices architecture and that they can deploy new things, they suddenly start doing new versions and new upgrades to their system, something along the lines of once every 6 weeks. That ability to introduce new things, that ability to grow things is incredibly powerful. In fact, you know, when Abe was talking at the beginning of this talk about digital transformation, man, these guys are the poster child for digital transformation. I was talking with their CTO a while back, and she was saying that they had the choice of going with the Smack Stack, and the engineer who was trying to sell them the Smack Stack estimated that it was going to take them 18 months to implement all this stuff. Right? And when a software engineer or an architect tells you it's 18 months, you know it's not 18 months. Man, people get fired, people get hired, there's politics, you're figuring stuff out. 18 months really turns into 22 months, maybe 24 months, maybe 26 months. And problems in design turn into a never-ending headache of support issues, right? That implementation is very difficult to maintain. With this methodology, by following these capture, route, transform, compute, and cook, right, we were able to do this in 4 months. And for those of you crunching the numbers, for those of you thinking 250,000 to 10 million a month, that's a revenue difference of $30 million by choosing the right information. Right? And they're leveraging technology to transform how they do business. Now they're not just doing what you asked them to do. Originally, when you went onto their website, you're saying, hey, I want a room, and I want it to be at Caesar's Palace, and they gave you a room. And now they're giving you a fully immersive experience. They actually just won a Loyalty 360 award program for that immersive experience. When you go to Vegas and you say, I want a room at Caesar's Palace, they know who you are. They can tell you the kinds of shows that you want to, based off of your history, the kinds of shows that you want to see, the kinds of restaurants you want to go, the kind of events that you're going to be interested in, right? They are generating a lot more revenue for MGM, and the customers are walking away a lot happier. In the biz, we like to call that a win-win, when people are really happy about what they're doing. They are literally transforming the business from a narrow-focused customer response into a 360-degree view about what that customer is doing. That's a contextual view of a customer and his life and his interests and her interests, I apologize, of his and her interests, and things of everything that they came to their resorts for, be it Vegas or be it worldwide. They're also starting to deploy these technologies because of that ability. And this is another great example of this, the ability of snapping stuff in, because you're narrowing your business focus in microservice, they're starting to snap stuff in of fraud detection. Fraud detection used to be the province of credit card processing companies only, right? But now people can start doing their own fraud detection. They can tell fraud detection on their customer basis. They can also tell fraud detection from their vendor basis as well. They're able to tell when a vendor is messing up, right, as well as when a client is going to be canceling or is trying to do some sneaky stuff. Right? And we did this using the X platform. The X platform is an intelligent transactional system that allows you to easily build, manage, and extend without compromising. And it's the compromising thing is the key. Without compromising on performance, reliability, scalability, and agility. That compromise, that 80-20 thing, that Spotify made a difference, or made a conscious decision to doing, right? Originally is a good idea. But as things become individual transactions, as people are looking for, I don't want just a general idea of where my ads are going, of what transactions I'm doing, of what songs I'm buying. When I want to know incredible specifics, that compromise is no longer a viable option. We do this. We're able to get you that performance, the reliability, the scalability, by leveraging 3 things, right? We leverage the microservices architecture. We have a unique, novel way for managing private state data, and we provide you exactly once transaction processing. That exactly once processing is important when it comes to reliability and simplicity. You're able to write to memory without fear of data loss. That private in-state memory brings you that speed and simplicity. You don't have to understand massive data models, 1,500 tables, 2,000 tables in order to integrate with your system. You're working with your private state. Right? And these microservices bring agility, resilience, and horizontal scalability. You need to be able to scale horizontally. You need to be able to scale out on different business keys instead of just being able to scale out on different products. And I think that brings me to the end of my my speech. Thank you all for joining. Do you guys have any questions?